Now, I could be wrong, but here is a pH tester. It's called litmus paper. Here's the scale. Okay. 7 being neutral, 8 being basic, down to 1 being the most acidic, and 14 being the most basic. Okay. Acid. In radioactive material, like right now we're giving out 0.25 microteslas here in this water from this tap filter. Okay, so like it has increased from earlier, but technically, if this water had enough nuclear radiation in it, okay, this little piece of litmus paper and this would probably be a lot higher, because in unified field particle theory, if a radiation can ever produce an ionic energy that can be reduced into subfrequencies through a material by, like, say for instance, moving around like this. When we move it around like this, if it starts producing more energy at that rate, because it has an effect like even hysteresis, where it'll charge an electric current through the material if it catches an atom, even though it's gamma radiation or X-rays mostly, and then alpha particles and beta particles, beta meaning electrons, alpha meaning like protons and neutrons. Well, if that's radioactive, which doesn't appear to be too radioactive, maybe partially, I don't know. However, this reading doesn't mean that is an extreme amount of energy, or does it mean that any of this is really all that radioactive. However, there may be some forms of higher electromagnetic radiation in the area, and I don't know about alpha or beta particles or nuclear particles or radioactive particles being in this area, but technically, if this was pretty extremely radioactive, this litmus will give a color from 7 on the scale. Even though there could be other things in the water like hydronium or any kind of acid base or material that's slightly ionic or electric, might give a slight color or even more. Okay, so now basically I show you what this litmus does. It's supposed to change immediately in the form of a real acid, real base, or any serious charge. Even a nuclear alpha particle or a beta particle or a gamma ray or an X-ray, there should be some acid produced, or electrons or protons or even neutrons that should actually cause a charge in the material. Probably. You know, we do have nuclear energy devices that collect the charge from nuclear radiation. So if this is dense enough and it has enough volume in that water and there is enough nuke in there, it probably would change the color. As you can see, we do actually have a slight color change. So like, it's not quite the 7 or the 8. It's much lighter. So really, it's basically pretty well neutral, and that means that it's not truly extremely radioactive or anything. So that's one way to test water. Then the other way is with one of these pH meters. This is specifically a pH meter. And then we have another meter that goes to this lid here. And then you can also do buoyancy tests with one of these. This is called a graduated cylinder. Now I want to show you content reading. I'll go grab it real quick. We have the content reader here for radioactivity, or I mean for mineral content or atomic other than water content. And if this hasn't been adjusted in any way, shape, or form, it should be right. And according to the science of that filter, it's pretty right, because that's an osmosis filter. So what we do here, we turn this on to 0. 0 is the most pure water. And this is called a TDS-EZ. They're electronically solving with a chip the electric conduct across 2 prongs of electric. You stick it down to about this hole here, and you get a reading of the water. And we're getting about, that's a ppm gauge, so 16 to 13 parts per million. Okay, so that's not too bad, but technically that dosage of water could be really poisonous to you. But if it's organic matter or some small minerals, it won't hurt you at that point. Not as much, unless it's like hot heavy metals or lead or nuke or something isn't supposed to be in there, like lithium or anything like that. So like, you really need to have a specific mass spectrometer tested at this point when you use one of these filters, because they're really not as perfect as you might think. So this water doesn't appear to be nuclear, not really, and it appears to be a low dose parts per million compared to the fact that normally the water is about 119 to 180 150 parts per million, which is typically around the United States standard. But that United States standard is very unhealthy. It is disgusting. I'm extremely allergic to United States water in all the counties that I've lived. And we tested it thoroughly. I cannot even attempt to take a shower in United States water. It's off limits. I can hardly bathe in it. It even has lots of material I've taken pictures of, like bacteria, funguses, different kinds of algae, poop, fibers, dirt, disease. It's filled with viruses. It's disgusting. It is. The United States could even be using it as a weapon for different places. You don't know what people are doing. There are criminals everywhere in the world. They lie about everything. So if this is accurate now, you may not assume that it is, but generally there is a fundamental principle here, is that purity can be measured. Okay, you can also smell water, taste water. There are certain pure tests that you could do. They're absolutely physical to attain the measurement of pure water itself. And then just guessing about the electrical conductivity of different elements in the water, that probably takes a while to figure that out. And you probably do it with like some probably a microcontroller unit or something like that. Make your own water tester, whatever. And then you can also do gravity tests. You could do all sorts of different things, but that's pretty much it. So this is about how you simply test water in the world today. But that's pretty much it. We're going to leave it at that. So thanks for watching.